Section 20.1 Crystal Field Theory. D. Thermochemical correlations. As the ionic radius of the 3D transition metals, all with a 2+ charge, decreases from left to right across the period, we can observe a trend in their hydration energies. Their hydration energy increases almost linearly if we exclude the ligand field stabilization energy. So now let's look at the experimental data from calcium 2+ all the way to zinc 2+. We have this 10 transition metal ions plus this calcium 2+. Now let's look at the magnitude of the enthalpy of hydration from here to here to here to here and then here. So these unfilled circles are the experimental data of the hydration enthalpy of these metallic ions in water. And then obviously there's a hump here and another hump here. So why do we see these two humps in the hydration enthalpy plot? Well, this is simply due to the ligand field stabilization energy. So we can subtract the LFSE from this hydration energy. And then we get this field circles. All right, field circles. Over here, this is Mn2+ with 0 LFSE because in Mn2+ you have 5 d electrons. And because water is rather weak field ligands, this Mn2+ adopts the high spin electronic state. You have 3 electrons occupy the lower energy T2G orbitals, and 2 electrons occupy the higher energy EG orbitals. So overall, the LFSE cancels in magnesium 2+ when it's surrounded by weak field ligands. So that's why LFE is 0 here. And obviously for zinc 2+, since you have 10 d electrons, the LFSE is also 0. In here you have 0 d electrons, therefore LFSE is 0. So again, if you have completely filled d orbitals or completely empty d orbitals, the ligand field stabilization energy is 0. What about the d5 case? When you have 5 d electrons in the high spin electronic state, the LFSE is also 0. So that's why you can see this all have a 0 LFSE. And then if we subtract this LFSE from some other metals, we get a approximately linear trend here. So from calcium to zinc 2+, the ionic radius decreases because the effective nuclear charge increases. And then we observe this approximately linear trend after excluding the LFSE. So these two humps indirectly suggests the existence of the LFSE in those transition metal complexes. So there's a homework problem on this. You can make Excel. You can tabulate the enthalpy of hydration for these metals, and then you can compute the LFSE, the ligand field stabilization energy, and then you can make your own Excel plot similar to this one.